right, today we're going to start our rational unit, and we're going to start with the most basic of rational equations, which is the inverse variation. To do that, let's go ahead and recall what you learned in Algebra 1, which was the direct variation. Direct variation was when you had some equation y equals some constant times x. So that right there was the constant of variation. It was basically a linear equation with no y-intercept. So we just have the y equals, the slope right here is that constant of variation times our variable x. That is the direct variation equation, and it looked like this. Again, a linear equation that goes right through our origin here. It can't be moved up or down or would not be considered the direct variation. In this case, as our x gets larger, so does our y, because x is being multiplied times something, so it's getting even bigger. For the rational unit, we're going to do inverse variation. So if y varies inversely with x, then as the x increases, the y decreases. So in this case, they're doing the opposite. In direct variation, they were both doing the same thing. Here, when the x is increasing, the y is decreasing. And if the x is decreasing, then the y is increasing. Doing the opposite. And that equation is y equals k divided by x, where k is the constant of variation, and really k has to be greater than 0. So in this case, we have y equals some constant divided by x. Again, this is a constant, so it's going to be a number, not a variable, divided by our x. So how do we find k? It can be found by multiplying the y and the x, because if we were solving for this k, we would multiply that x to get it to the other side. So k is equal to y times x. That part is important right there. To find that constant of variation, we multiply the y and the x value. If you think about this graph, it's going to look like this. It's got two pieces, one piece in the first quadrant, one piece in the third quadrant. That is our rational equation, the one that has the two pieces. So this is the most basic of rational equations, and that's the unit that we're starting now is the rational. So we wanted to start with this basic one here of inverse variation. We're going to talk about a couple scenarios here where inverse variation takes place. It says the time to complete a job varies blank with the number of workers working. So if we think about the more workers that we have working, it should take less time. Since both of those are doing the opposite, that would be inversely. The time it takes to complete a specific trip varies with the speed of travel. So the faster I go, the less time it's going to take. So that would be inversely. And the number of gallons of gas in a car varies blank with the number of miles traveled. The more I travel, the number of gallons of gas are going to be up as well, because the further I go, the more gas I'm going to need. So this would be directly. All right, so when you see those terms there, inversely and directly, that points out to what kind of equation you're going to use. If you see directly, you want to use that y equals k times x. If you see inversely, you're going to want to use that y equals k divided by x. So in our first example, it says the number of songs on an iPod varies inversely. As soon as I see this, I know I'm going to be using the model y equals k divided by x. And I'm using y and x, but really you can use any variables there. The important part is that you understand that there is a constant divided by that variable. So the number of songs on an iPod varies inversely with the average size of a song. An iPod can store 2,500 songs when the average size of a song is 4 megabytes. So the first thing I would want to do is find the K so that I can write the equation. So here's my number of songs, N, is equal to some constant divided by the average size of the song. So I'm going to call that S. So N is the number of songs and S is the size. So I would go ahead and multiply this 2,500 times 4 to find that K, because 2,500 is the number of songs and the size is 4 megabytes. So we get our K is 10,000. It's important that you get that K so that you can write the equation, because again, that K is not a variable, it is a number. So our equation would be N equals 10,000 over S. That's the equation when you plug that K back in. And then find how many songs for 5 megabytes. Well, then we would use this equation that we've written. So we get N equals 10,000 divided by 5, because that's the size. And that is 2,000. So we find the K so that we can write the equation, and we write the equation so that we can predict other information. In some cases, they won't give it to you as a scenario. They'll just give it to you with the variables. So that's what we're going to look at next. It says if y varies inversely with x and y is -3 when x is 4, find the constant of variation and the equation relating x and y. Then find y when x is 6. So in this case, this is just math terms. It's not really a problem situation, but you would do it in the same way. Inversely, right there, tells me that I am using the form y equals k divided by x. Then they are giving me this information right here so that I can find K. That's the purpose of them giving you that information, is so that you can find that constant of variation. So we get -3 is equal to K over 4. We multiply to find that K. Now we can write our equation. So our equation is -12 divided by x. And in problem situations, that constant of variation is going to be positive. In this case, because it's just a math equation, we just threw numbers out there for you. If they were asking for the equation, here is what you would write. That is the equation. If they are asking for the constant of variation, this is what you would answer. So it's important that you know what these terms are so that you can answer the correct question when they're asking. A constant of variation is this number we found here. The equation is once you have plugged it in. You do not want to write y equals k over x as the equation. That is not the equation. This is our equation. And then, of course, we use the equation to predict information. So then find y when x is 6. All I have to do is take my equation and plug in 6 for the x. That gives me y is equal to -2. So there's a couple different questions that they can ask you on a quiz or test. They can ask you for the constant of variation, they can ask you for the equation, or they can ask you to predict right here. So that you would want to write the equation and then use it. All right, we'll look at one more problem situation here. It says the diameter of the string of a violin varies inversely with the frequency of its pitch. If the diameter is 5 millimeters, the pitch is 500 hertz. Complete the table below that shows that frequency. Y is a function of the diameter x. All right, so they did give us one situation here. When it is 5 millimeters, it's 500 hertz. So they gave us this part of the table right here. In order to fill in the rest of the table, I'm going to go ahead and write the equation, because since it says varies inversely, I know which model it's going to look like, that y equals k over x. So our diameter, I'll go ahead and write down here, our diameter is some constant divided by our frequency. So we get 5 is equal to some constant over 500. Now again, to solve for that constant, you multiply. So you're going to multiply 5 times 500. And so our constant is 2,500. Now we can write our equation for this. And so we get D is equal to 2,500 over F. Remember, once you plug in that constant, that is when you have written the equation. And so now to use that equation, we can use it to fill out the table and we can use it to predict. So I'm going to go ahead and just show you on the calculator here so that we can look at the equation and look at our table. We get 2,500 divided by X. That's our equation. Now we can go to our table here. Now the calculator is set up to go by ones, but in this case, our table is going by hundreds, so we want to go up a little bit faster. So I'm going to hit second window, and it tells you where to start the table. So I'll go ahead and start it at 0, and then I want to go up by 100 instead of 1. So that's just a quick little calculator tip to use that for a table. So I'm going to go to my table now by hitting second graph. And so at 100, it is 25. Let's scoot this over. At 200, it's 12.5. At 1,000, it is 2.5. I'm going to go ahead and move my table down a little bit further to find that 1,500, and that is 1.67. At 2,000, it's 1.25. And at 2,500, it is 1, since we're doing 2,500 divided by 2,500. All right. Since we've got this in the calculator, I'm going to go ahead and show that to you on the graph, just so that you can see that rational. And so on my window here, I've got negative 10 to 10. I'm going to go ahead and increase that. Just like the tables all the way to 2,500, I'm going to do that to 2,500 here as well. And I'll go ahead and do negative 2,500 so we can see that other side. Now our y's are not growing that fast. They're going from 1 to 25, so I don't need really large y's. So I'm going to go up to 30, let's say. So I'll do negative 30 to 30, and that should give me a good window. And here is our rational. So that inverse variation is a rational. We introduced you to this at the beginning of the year, so you can get used to what that graph looked like, but that's the unit that we're working on right now, is that rational one. All right, the last question says if the diameter is 20, what is the frequency? So in this case, they switched up which variable they're giving you. So we would plug in the 20 for the diameter. And we are looking for that frequency. This is just like a proportion. Whole numbers are over 1, remember that? So this is just a cross multiply. So we get 20F is equal to 2,500. Oh, you can't see that. Kind of ended at the bottom of my page there. So we have 20F is equal to 2,500. Our last step would be to divide by 20. And sorry, I'm running out of space there. So we take that 2,500 and we divide by 20. And so that is 125. So our answer here would be 125